Hello and welcome. In our last video, we covered the theory of bit shifting and rotating. Today, we move from theory to practice. First, we'll explore the two most powerful real-world applications for these commands, and then we'll jump into a live PLC programming demo where I'll show you, step by step, how to build a rotate right function and avoid the common pitfalls. Let's get started. The why, real-world applications. So, why are these functions so important? Let's look at two key examples. Application 1, the digital conveyor belt. Imagine a production line with 16 steps. Some work pieces are green and need special treatment, while others aren't. We can represent this with a 16-bit word, where A1 means the piece is green and a 0 means it's not. As the conveyor belt moves one step, we simply shift our bits one position. With every step, the entire pattern shifts. This allows our program to know exactly which workpiece is at which station and whether it needs special handling. This is called a shift register, and it's one of the most valuable applications for these commands. If the process repeats, we would rotate the bits back to the start. Application 2, lightning fast math. The second application is a clever math trick. If you take the number 1, which is 0001 in binary, and shift it left by one position, you get 0010. Which is the number 2. Shift it left again, you get 0100, which is the number 44. Shifting left is the same as multiplying by 2. Shifting right is the same as dividing by 2. While modern controllers are powerful enough that you can just write times 2 in your code, this method is incredibly efficient and crucial on a microcontroller or assembler level. Alright. Let's jump into the code. Step 1, add the instruction block. In our PLC program, we'll go to the instructions, find the shift and rotate folder, and drag the ROR or rotate right block into our network. You'll see the block has a few connection points or pins. Step 2, connect the inputs. First is the EN or enable pin. We want this function to run when we press our rotate right button. So I'll add a normally open contact link to that button. Next is the IN pin. This is for the data we want to rotate. I have a variable I've created called variable word, which I'll connect here. Notice the block automatically detects that this is a word data type. Then we have the N pin. This determines how many positions we want to rotate by. For now, I'll just type in a constant value of 1. Step 3, connect the output. Finally, we have the out pin. This is where the rotated value will be sent. In most cases, you want to rotate the variable in place. So, I'll use the exact same variable underscore word tag for the output. Section 3, the common pitfall and the fix. Okay, let's download this to our simulation and see what happens. Look at that. As long as I hold the button down, it rotates uncontrollably, thousands of times per second. This happens because the EN pin stays true for as long as the button is pressed. We don't want that. We want it to rotate exactly once per button press. The fix, edge detection. The solution is to use an edge trigger. We'll modify the contact on our EN pin to be a positive edge trigger. This tells the program to execute the command for only a single scan cycle, the very instant the button is first pressed, no matter how long you hold it down. Now, let's download again. Perfect. It doesn't matter if I press it quickly or hold it down, it rotates by just one position every time. Always remember to use an edge trigger for single shot operations like this. Section 4. Important final tips. Before we wrap up, here are 2 critical gotchas to be aware of. First, match your data types. If your input variable is a word, 16 bits, but you accidentally set the instruction to operate on a byte, 8 bits, you're going to have a problem. As you can see, the rotation is now cutting off half of our data. It's only rotating the first 8 bits. So always make sure your data types match to avoid losing data. Second, shifting versus rotating. The rotate instructions typically only work with bit sequence data types like word or byte. However, the shift instructions can also work with numerical data types like integers. This is because shifting is used for that multiplication and division trick. But be careful. When you right shift an integer, the program handles the sign bit, the plus or minus bit differently to keep the math correct. Just remember, the TIA portal is smart and will often guide you to the correct data type. And that's the practical guide to using shift and rotate operations in your PLC. We covered the real-world use cases, how to program the instruction, and the critical importance of using edge detection and matching your data types. If you found this video helpful, please hit the like and subscribe buttons. It really helps the channel grow. If you have any questions, leave them in the comments below. Thanks for watching, and I'll see you in the next video.